Ladies and gentlemen, please welcome to the stage leading technology analyst and industry thinker, Benedict Evans.
Hello.
Thank you again. Thank you so much for being here. Floor is yours, and I'll see you in a bit.
Thank you. So, I was asked to explain everything about AI and everything else, and only take half an hour and not talk too fast. I'll probably manage 2 of those. You can judge the others yourself. I think a good place to start, if we want to understand this, is to ask, well, what is it that we mean when we say AI? This, I think, is a good description. This is an AI pioneer from 1970. He said, AI is whatever doesn't work yet. Because once it works, people say, well, that's not AI, that's just software, that's just technology, that's just a computer. And 10 years ago, machine learning was AI. If you took a picture of your dog and your phone recognized it, that was magic. 20 years ago, it was science fiction. Now it's just software. And if we think about the progress that we've gone through in the 1970s, databases were AI, and there were lots of movies about how databases were evil and scary and were going to take over the world. 10 years ago, machine learning was AI. Now large language models are AI. And it does seem like AI is a sort of linguistic concept that means anything that doesn't work yet or anything that's just started working. It's like saying technology or automation. Once it works, it's not technology anymore. It's just the thing that's always been there. And so there is a question here. Is this new technology, are large language models, going to be more the same? Are they going to be another new, interesting, important technology like machine learning, like databases, like the internet? Or are they going to be something bigger than that? And so this is Bill Gates. The younger people here, ask your parents who Bill Gates is. Bill Gates saying, no, this is something more important than that. This is the most revolutionary thing he's seen since the graphical user interface. And Sergey Brin, who's the co-founder of Google, again saying, no, this is going to take us to AGI, which is a way of saying this is going to take us to something that is intelligent in the way that people are intelligent, or maybe more intelligent than that. And so if we think about the progression of technology over the last 50, 60, 70 years, one useful way to understand it is that it's moved in platform shifts. So every 10 or 15 years, there's a new thing that becomes the center of the industry, and that's what all the innovation and the investment and the company creation is in. So from the mid-1960s to the 1970s, we had mainframes, and then PCs, and then the web, and then smartphones, and smartphones are now sort of 15 to 20 years old. And so then there's a view that says, well, generative AI is the new thing. This is what all the new companies will be built on. All the cool, new, exciting, sexy stuff will be built with generative AI. And then in 10, 15 years, there'll be something else, and we'll just carry on with this progress. There's another view that says, no, we've broken the cycle. This is a much bigger change than the internet or PCs or the web. It's a much more profound change in the nature of humanity, in the nature of technology, in the nature of the things that we can build. And so that gets you to kind of a spread of possible outcomes. There's one view that says this is going to be like iPhones or databases or software. And if you were to say, how many AIs will there be in the world, that would be like saying, how many spreadsheets are there? It's kind of a meaningless question. And the other view would be that there will be kind of one giant felt computer that will just control everything. And you can ask it to do your taxes or buy your house or help you move country or do anything you want. And it'll be able to do all the things that software used to do and a whole bunch of new things that software couldn't do. The problem with all of this is we don't really know. This is Larry Tesler in 1970 again. On the left, Marvin Minsky at the same time, another prominent AI scientist who thought we would have computers that were as intelligent as people in like 3 to 8 years. And he was right. We will have computers that are as intelligent as people in 3 to 8 years. And that may be true in another 50 years' time as well. We just don't know. We don't know whether this technology will scale, whether it will keep improving to the level that we had some kind of software like that, or whether this will end up like databases or spreadsheets or smartphones. And so that means that in the tech industry today, there are 2 very different kinds of conversation. On the one hand, there are lots of people building models, and there are lots of people creating software and creating tools and going out and building products. And on the other hand, there are people saying, holy fucking shit, this is going to transform humanity, and maybe it will kill us all. I tend to be on the left side of that. The problem is we don't really know how this technology will progress. But at the moment, that's where we are. So what's happening right now? Well, there's a lot of model building. ChatGPT started working almost 3 years ago, and since then, everybody else started trying to build stuff too. So there's been a huge amount of capital invested. The prices have come down a lot. There's lots of exciting new technologies, lots of new acronyms, lots of new buzzwords and terminology. But what's really happened is that there doesn't seem to be any obvious moat. That's to say, there doesn't seem to be any particular differentiation, any particular barrier to entry, any particular winner-takes-all effect, any reason why there would be only one company doing this. And we've had a huge wave of open source, which means that anybody can go out and download the latest models for free and run them on their computer. So you can go out right now and download DeepSeek's latest model, or Google's latest model, or Meta's latest Llama model, and you can download it onto a high-end PC and run it at home today. The only drawback is that if you're in Europe, you've just broken the AI Act because this is a systemically dangerous model, and you need to get a lawyer in Brussels before you're allowed to run that model. And I'm not joking, by the way. The cutting-edge models you can download now are illegal for you to download in Europe unless you go to Brussels and get a lawyer, because they're supposed to be systemically dangerous. I don't know what that means. Maybe you should put them in a plastic bag with some bleach or something to stop them escaping and killing us all. But otherwise, the technology is becoming a commodity. And so to put some data on this, last year, the big four cloud companies spent about 220 billion euros building infrastructure to run these models. This year, they will probably spend something over $300 billion building data centers to run these models and build new models. A large portion of that is coming from their existing cash flows, but it's just kind of worth looking at Microsoft. I'm old enough to remember when Microsoft's business was putting a $1 CD in a $10 box and selling it to you for $200. That was a good business. So this is Microsoft's CapEx to sales. Microsoft was spending very little on CapEx. Now, this year, it thinks it's going to spend something like a third of its revenue on CapEx. So there's an enormous surge of investment going into this. A lot of this money is going straight through to NVIDIA, which has the most extraordinary chart here. This is comparing it with Intel. NVIDIA's chart is just going up and to the right every quarter, and they still can't keep up with demand, and the people building the data centers can't keep up with the demand either. But what all of that investment is getting us, it seems to look like a commodity. So this is a plot of all of the models that have been released on a score of quality on the vertical axis, and then horizontal axis obviously is time. It used to be that OpenAI were ahead. Now OpenAI is kind of first amongst equals. And DeepSeek, at the end of last year, this is a Chinese hedge fund, spent about $500 million to build a cutting-edge model. DeepSeek really just kind of demonstrated the point. Anybody with $500 million and a lot of engineers can build a cutting-edge large language model. And $500 million isn't nothing, but the tech industry is a big industry now, and there's a lot of people who have $500 million. And so there is something between probably 10, 15, maybe 20 organizations that are building cutting-edge models and pushing these charts forward. In parallel to that, of course, there's been a huge increase in efficiency. So note that this is a log scale chart. So this is the price to deliver equivalent performance to OpenAI's model ChatGPT-4 and then model 4.0. And so there's been multiple orders of magnitude collapses in the cost of creating any given cost. So you have the money pushing in two ways. On one hand, getting a better result is more money. On the other hand, the cost of achieving today's result collapses by probably 100x in the course of a year or 18 months. Now, there's a bunch of people who look at this and talk about something called the Jevons paradox, which basically says if you make it cheaper to do something, then people will do it much more. And this is true. This is price elasticity. Some people in here will know about. But if something gets cheaper and people do more of it, that doesn't necessarily mean that there's more money. This is what the telecoms industry has learned in the last 20 years. We're all streaming high-definition videos on our phones and paying less than we were paying 20 years ago, just because telcos have had to invest money to support that. And meanwhile, the kind of more interesting way of thinking about pricing is that you now have a very steep pricing curve. So you can have the latest, best possible model, or you can have a model that's sort of 90% as good for about 1, 2, 3% of the cost. And then if you wait a little bit longer, you'll probably be able to run it on your phone as well. So we have this very, very steep cost curve based on whether you want to be absolutely the best possible or whether you can put up with being almost the best. Now, for a certain kind of generation, all of this feels a lot like looking at the PC industry in the 1980s or 1990s. You would see magazines with covers like this, like, we test the 50 best modems. We test the 191 486 PCs. If you buy an iPhone today, it's probably faster than about 1,000 486 PCs, maybe 10,000 486 PCs. And the reason I make this comparison is, like, if you don't need to know this anymore. You just buy an app. You just buy a laptop or you buy a phone, and you don't really need to know any of this stuff. But there's a period when the market evolves, when you have this explosion of innovation and investment and creation, and there's lots and lots of acronyms and lots of benchmarks, and you need to know how many megahertz things are, and how many gigabytes, and how many sockets you have, and then it all just gets abstracted away, and you don't need to know that anymore. And that's kind of where we are at the moment. The one thing that is interesting is that although the models themselves seem to be commodities, the companies are not. So this is the App Store chart from Apple. The models behind each of these companies are kind of equivalent, but the only one any consumer's actually heard of is ChatGPT, which is quickly seems to be becoming a verb. It's becoming ChatGPT something where we talk about Googling something. But this is kind of a question of distribution and marketing and brand. It's not really a question of the underlying technology. Meanwhile, the big platform companies themselves are all picking this up and trying to fit it into their existing strategy. This is always what happens. Whenever there's a new thing, the incumbent says, well, we'll make it a feature. Of course, we've already got that, and we'll add it to what we're doing. And so Meta is trying to make this a commodity. Amazon and Google and Microsoft has cloud platforms, so they want to sell access to this on the cloud. Everybody, of course, wants to make it a feature and incorporate it into their existing products. But really, all that anybody who isn't a Microsoft or an NVIDIA shareholder needs to know is that there's a huge amount of money going into this. There's a huge amount of progress. But fundamentally, these things are getting very cheap, and they're really becoming commodities. And all of the value creation, all the innovation, all the investment for everybody else is moving further up the stack. And so that gets to a question for everyone else, which is, like, how do we deploy this? What do we do with this stuff? How is this stuff actually going to get used? How is it going to get presented to us as consumers? And there's a bunch of kind of really puzzling philosophical questions in thinking about what a large language model is. Now, I consciously didn't come and spend an hour explaining large language models or explaining the concept of machine learning, because I figure this is a fairly sophisticated audience, although I don't know, I might be wrong. But there's a sort of a basic shift in what this technology does, which is that all previous technology, all previous software, indeed all previous automation, was fundamentally deterministic. It did exactly the same thing in the same way every time. So a typewriter, a sewing machine, a production line, a machine tool, a database, a mainframe, a bank's computers, they all do the same thing in the same way, the way you told them every single time. And so they're very, very predictable. Machine learning was kind of different. Machine learning said, instead of making this a logic problem, let's make this a statistics problem. And so machine learning 10 years ago was able to solve a whole class of things that we couldn't do with deterministic systems. We couldn't get databases to recognize pictures or do translation or understand speech. There were kind of a broad class of things that traditional software just couldn't do. You couldn't get traditional software to recognize a picture of yourself or your children or your dog, or to recognize that that credit card transaction was weird, or to translate something between different languages reliably. It would always sort of work, but it never really worked. And so machine learning made this a statistics question, which means it became a probabilistic question. So it's not exactly the same every time, but it solved a bunch of problems as a result. And that's why now you can take a picture of your dog and your phone will recognize it. Large language models today expand that concept to say, well, instead of trying to recognize a dog, let's just try and do reasoning. Let's get something that looks kind of like it might be the same as human intelligence. And so again, it's probabilistic. It says, what would the answer probably be? What would an answer to this look like? What would most people probably say? What would a good answer to that probably look like? It doesn't say this is the answer. It's not a database. It can't give the same answer every time. And so there's a kind of a progression that I show on this slide, which is to say that databases do stuff that are easy to explain to computers. They're hard to do in your head. It's hard to calculate a mortgage in your head, but it's very easy to explain it to a computer. Machine learning did things that we couldn't explain to computers. We couldn't tell a computer how you know that that's a cat and not a dog. And machine learning solved that. And so maybe what large language models do is they do things that are easy to explain to people, or maybe easy to explain to a teenager, easy to explain to a human who doesn't have any context and isn't very clever, but kind of has a mammal brain. Now, that all sounds very interesting. There's an English joke about a Frenchman who says, that's all very well in practice, but does it work in theory? And you can spend too long kind of philosophizing about this stuff. But But it does mean it's kind of difficult to work out, well, what would you do with software that can automate things computers couldn't do before, but might get it wrong? What does that mean? What would you build with that? What would that work? How would that work? And then, as then probably anybody who's experienced trying to use ChatGPT or any of these other systems is, you kind of have a blank screen problem, like you've got this blank screen with a prompt and you've got to work out what to ask. And then if you don't get what you want the first time, you've got to work out how to ask it in a slightly different way and say, like, I asked you a question about philosophy. Now imagine you're a philosophy professor, a German philosophy professor, and you'll get a different answer. So you have to think about how to ask and how to steer the model. And you have to think about what it means that it might be wrong, and what kind of questions that's a problem for, and how you incorporate that into how you use these things. Now, this gets at kind of a higher level question. Is the right way to use these things that you put them inside traditional software? Do you bury them? Do you hide them behind other things that know how they work? Or do you just give them access to every other tool that we use so that they can get their source of truth from using Oracle? But whatever the answer is, today there's this kind of really interesting split in the data of how people use these, which is, if you look at a whole bunch of survey data, something like 5 to 10% of people in most of the developed world are using these things every day right now. And then another kind of 10, 15, 20% of people have got it, they've used it, they've got the account, they've typed stuff in, they've played with it, and they're using it like once a week, if that. And then another 10 or 20% of people have used it once and said, I don't know what to do with this. So there's this interesting puzzle is, who is it that uses it every day? And who are the people that look at it and say, I get it, but I kind of don't have a use for this? Because if this thing is supposed to be able to do everything, if this can replace all software, why do most people look at it and go, I don't get it. What's it for? You get something similar if we look at companies. So this is a survey of what is delaying large corporations in deploying this. And actually, most of them have worked out things they can do with it, which is use cases over in the right. But it turns out to be a lot more difficult actually to build something when you have to think about security and privacy and the error rates and the cost of doing this and where the data is. All of that gets me, of course, to saying, well, this is always the way every new technology works. So you can spend a long time saying, well, this is amazingly different and revolutionary and transformative, and we've never had anything like this before. But that was true of every other new thing, too. The iPhone was amazing and transformative and revolutionary when we'd never had it before. And this chart is a chart of adoption of cloud technology, which, if you work in the tech industry, is old and boring and done, and everyone gets it, and every big company is using this, except that actually big companies have only moved about a third of their stuff onto this technology after 20 years. In fact, if you go and look at technology adoption across Europe, there's a very wide spread between Northern Europe and Southern Europe. So in Northern Europe, everybody's using this, and in Southern Europe, most technology companies are still using mainframes and Oracle, which is technology from the 1980s. So it takes a while to deploy the new thing, even when everybody understands what it is. And you always have these questions of, this is dumb, this is stupid, we don't understand this, how would this work, what would we do with it? Now, I am old enough to remember when everyone was very excited about mobile internet, but none of us really understood that it was going to replace PCs. None of us really understood how big those changes were. And so it is kind of useful to think, well, yes, this is a completely different thing, but every new thing is a completely different thing in kind of the same way. So maybe let's ask a kind of a different way of trying to understand this then. If this is the same as every other new thing, how does that work? What tends to happen with every new technology? Well, you tend to get a couple of steps. So to begin with, we try and absorb it. We force it to fit what we're already doing. We get the new tool and we force it to fit the work we already have. Big companies make it a feature. People use it to automate the problems they already know they have, to do the things they already know they're doing. Then, after a little bit longer, people start working out completely new things. People work out new revenue, new products, different ways that you could do this, new things that you could build that you couldn't have built with this before. And then every now and then we have something that tech people call disruption, which is you actually change the question. So the classic examples are Uber doesn't sell software to taxi companies. Airbnb doesn't sell software to hotels. Airbnb changes what you mean when you say a hotel. That might be good or bad. But Airbnb isn't a hotel, it's something else. And it takes a while to work out what those things are. But I think, again, it's useful to go back and look at another time we've had one of these kind of fundamental changes, which is to look at spreadsheets. And most people, certainly young people, don't really know this, but before we had software spreadsheets, spreadsheets were paper. You can actually go on Amazon now and buy a pad of spreadsheet paper. And so if you were an accountant and you wanted to work work something out, you would fill in all of the cells one by one by hand with a pencil. And if you wanted to change something, then you just need to go and recalculate all the numbers. So, and then Dan Bricklin creates this thing called VisiCalc, which runs on the Apple II here. Incidentally, this computer to run this cost about $15,000, adjusted for inflation. Like, computers used to be really expensive. And so he would show this to accountants, and he would say, look, you can change the interest rate here, and all the other numbers change. And we look at that and we think, yes. But if you're an accountant in 1978, you'd just seen a computer do a week of work in 10 seconds. And so if you were an accountant, you had to have this. This was completely transformative. But if you were a lawyer, you would look at this and think, well, that's very clever, and my accountant should see this. But I don't do spreadsheets, so I don't know what I would do with that. If you were an architect or a journalist or some other professional, you would look at it and you think, well, that's very clever, but I don't do those spreadsheets, I don't do that thing. I need something else, I need some other tool. And I think that's kind of where we are with generative AI today. There are some people in some professions with some kind of jobs who think, this is amazing, I have to have it. And the places we're seeing that right now are in software development, where people are already talking about 20, 30, 40% efficiency gains, like right now, before anyone's really built any tools. And also in marketing, again, there's a huge wave of adoption for this in advertising agencies. To some extent in customer support, although you have to be careful because the customer support system will tell you what sounds like a good answer rather than what is a good answer, which may or may not be what you want. And then early adopters who always adopt the new thing, but that's always kind of a limited market. It's worth, in particular, I think, looking at software development. This is a great quote from YC, Y Combinator, which is a Silicon Valley incubator, saying that about a quarter of their startups had 95% of their code written by AI. And so this is kind of a huge acceleration in how much software you can write, how quickly, for how much money. And it may be kind of a repeat of what we saw with AWS, which was a kind of an order of magnitude, 2 order of magnitude change in how easy it was for a startup to build something and take that to market and get people using it. For everyone else, though, there's this, I think, canonical quote from Steve Jobs. If you don't know who Steve Jobs was, get out. Where Steve Jobs said, it's not the customer's job to know what they want. It's not the customer's job to pick up a piece of technology and know what you're supposed to do with this. It's the job of Apple or Google or Microsoft to work out, well, why would this be useful and what would you do with it and how would you turn that into a feature or a product that people can actually use that becomes useful, that solves some problem for them. Now, one answer to that, of course, is that as a big company, you go out and hire Accenture, which is the kind of archetype of the company that solves technology problems for big companies. Accenture booked $1.4 billion of new generative AI work building stuff for companies last quarter. So this is more revenue than OpenAI. So for one kind of company, the answer is, we'll just go and do this through our normal IT process. There's another process, which is, this is why startups exist. Startups exist to discover problems, to realize that there's a problem there that no one had really thought of, and realize that there's a way that you can solve it, and then pick that up and use that to change that problem. And I think both of these kind of the companies, the examples that I've used here are kind of interesting, because you can spend a lot of time talking about AI in the abstract, and talking about what it means for democracy, and talk about intellectual property or rights or all these kinds of things. So this company is using large language models to help big companies migrate their code from mainframes to the cloud. This company is using large language models to help telcos reconfigure their billing systems. So this is not writing text or plagiarism or writing novels or making pictures. It's solving complicated automation problems inside the back offices of large organizations. In other words, it's just software. And of course, this is why software startups exist. This is again, I mentioned earlier, Y Combinator, an incubator in Silicon Valley. Basically, all of the new startups are building AI, and most of those are using that to build things for big companies, building it to solve problems for the enterprise. The other side of this is the companies themselves. Pretty much everybody now has a pilot, like 70, 80% of people have a pilot. As I said earlier, that's mostly concentrated in software development and marketing, but there's also a lot of pickup in other areas. There's also a lot of kind of hesitation because you do the pilot and it doesn't work. It's kind of important, I think, to break this out, because you can see some data that will just say, is your company using generative AI? Yes, no. Well, what does yes mean? It means the CEO has a ChatGPT account. It means somebody in marketing is using Midjourney. Like, what do you mean is your company using it? So it's kind of more useful, I think, to kind of get kind of specific and tangible and say, well, how much are you using it and what for? And have you gone from trials to gone to pilots? And the answer here is, yeah, everyone's piloting, experimenting, and a bunch of people have got some stuff into production. Again, that takes time. This is another version of the cloud adoption chart I showed earlier. This is Morgan Stanley surveying of CIOs. Have you deployed anything at all yet? And the answer is sort of 30–40% of people have either got one thing in deployment now or plan to, but another, like, 40% of people don't plan to do anything until next year because they've got other stuff on their mind. And so it will take a while. But as you go through that process, this is what always happens with software, you get more tools. You get more things that you can do. And so as we went from mainframes to PCs, to mobile and the cloud, we went from having one or two pieces of software to having hundreds and hundreds of different pieces of software, different tools that solve different problems, that automate new things, that increase efficiency, that free us up to do more stuff. And so that gets us to this question, well, what are the new things that we're going to automate with LLMs? Hence, I go to a lot of kind of organizations and they ask, well, what is our AI strategy? How would we work out what an AI strategy is? What would that mean? And I think the answer is, well, what kind of question are you asking? Are you asking a strategy question or an IT outsourcing question? Is this kind of an Accenture question, or is this a Bain, BCG, McKinsey question? And the answer is probably all of the above, and that's always how these new changes happen. I mentioned Airbnb and I mentioned Airbnb and Uber earlier. I think it's kind of interesting to dig in and think about how those change their industries. Because on the left here, you see a chart from New York of of Uber versus taxis. And what happened is that the taxi market more or less collapsed and everybody uses Uber instead. There's still a little bit of taxis left. Uber unlocked a whole new demand for taxis for people who couldn't get them before, for drivers who couldn't get a job as a taxi driver, for people who didn't have access to that service before, and so expanded the market. On the other hand, Airbnb hasn't really had much effect on hotels at all. It unlocked a different kind of demand for a different kind of travel, for a different kind of consumer. So there's it's easy to talk about disruption or change, but that can look very different depending what industry you're in. The live topic at the moment is, particularly for anyone in publishing, is, well, what does an LLM mean for the internet? What does it mean for web? What does it mean for search? Because if I go and search for a recipe in the past, Google would give me a website, and I'd go and read the publisher, and I'd see the person who'd written the recipe, and I'd get it from them, and they would make money from that. But now I can just go to ChatGPT and say, well, what's a good cookie recipe? Or I'm going to Rome next week, what are 5 good restaurants? And you don't drive the ad revenue, you don't support the publishers, the content is just abstracted away. Now, that's kind of a first-level question. This is a problem we already know that we have that we can automate. The thing I've shown on the right here, this is just kind of a thought experiment. I took a photograph of my fridge. Fortunately, it's small, so you can't see it and judge me. There is some ricotta and some wine and some pasta. But all I did was take a photograph of my fridge and say, what should I cook? And you can see it's looked at the picture, worked out what's in the fridge, and started making suggestions. That's not how Google works. That's not how the web works. That's a very different way of answering that kind of question. And of course, behind that question is roughly $1 trillion. So the global ad industry is almost exactly $1 trillion. About 20% of that is in China. Amazon, Meta, and Amazon have half of all of the rest. And where does that money move if I go to ChatGPT and say, what life insurance should I buy? Or what car should I get? Or what's a good cheap flight to go on holiday? And all of the advertising and all of the ecosystems that have grown up around that, which is $500 billion a year, where does all of that move? I think there's a kind of a higher level point here, which is that the tech industry changes how industries work. But then all of those questions are not really technology questions. So I've just talked a little bit about how AI will change search and discovery, recommendation, brand, and retail. That's not really an AI question. That's a question for anybody who runs a store or is trying to sell something to consumers. Everyone now is very excited about AI enabling humanoid robots. So you can actually have a 2-legged robot that walks around and doesn't fall over. It's very, very cool. I don't really know why it's useful. But if you think that's going to change the warehousing industry, you need to talk to people who work in logistics. It's not really a technology question, it's a logistics question. The same thing for AI video generation, the same thing for translation. all of these will become capabilities that will change how other industries work. And that leaves me with a couple of final observations. I've been talking about AI mostly at events like this for the last 2 or 3 years, because that's the new thing. And I always get questions, and it occurred to me that the questions always fit into 2 categories. The answer to the question, any question about AI, is almost always either it will work like every other platform shift. So how did we do cloud? How did we do mobile? How did we do SQL? How did we do databases? How do we think about the internet? Well, the answer is probably the same. And the other class of question is nobody knows. Like, will these models scale to the point that they can take over the world? Will they scale to the point that we don't have to worry about error rates? Will they get cheap? Will you be able to run the best models on your phone? We don't really know. We'll have to come back in 5 years and find out. But it is, again, worth remembering we never know. So this is a diagram that somebody did of the internet in 1995. Except it's not called the internet, it's called cyberspace, which is a really 1990s word. And within that, they have something called the matrix, which is a very 1990s word. That's when Keanu Reeves was young. And the point of this diagram is it was clear that everybody was going to have some kind of computer thing connected to some kind of network doing something. But it wasn't clear what that meant. Was it going to be the internet? Was it going to be a PC connected to the internet? Or maybe it would be something like AOL, or maybe it would be something like Minitel. What if it's, okay, so it's going to be the internet. Well, there's lots of internet things. Is it going to be Gopher? Or is it going to be FTP or the email? No, it's going to be the web. And how is the web going to work? And where is the value going to be captured in the web? Remember that Google didn't exist at this point. Now, Google made a bunch of money from search advertising. There was no search, never mind search advertising. And Facebook then made a whole bunch of more money from social, which didn't exist until 10 years later. So you can believe absolutely that this new thing is going to be very important and really not know anything about how it's going to work or where the value is going to be. There's an old joke that newspapers looked at the internet and said, this is going to be wonderful, we won't have to buy as much paper. And they were right that they're buying less paper, but not for the reasons that they thought. All of which is to say, meanwhile, of course, all of the stuff that we were excited about before AI is still happening. So e-commerce is still going up and to the right. E-commerce is now 20 to 30% of retail revenue in most of the developed world. Even things like autonomous cars might seem to be starting to happen. Waymo, which is part of Google, has actually got autonomy working on a small scale. And so I think a way to end this conversation is to say that the tech industry is always very excited about stuff that's going to happen in 5 years, like crypto, VR, quantum, robotics, satellites. Right now, we're all building stuff about this one thing. But meanwhile, all the stuff that's actually getting deployed and the stuff we're using is still ideas from 5, 10, 20 years ago. Ideas like maybe people will buy stuff on the internet. Maybe people will watch video on the internet. These are wild, crazy ideas from 2000 and 1995 that are only now actually rolling through some industries and changing them. And so we will continue to see that progressing through to the future. I think with that, we have some discussion.